So today's topic is Ballerina. It's a programming language. I'll talk more about Ballerina in the next. So I have a little bit of slides and a lot of coding in VS Code. Let's see how it goes. So I'll start with what I want to cover today. So obviously I want to show you how awesome Ballerina is. That's my plan. Well, straightforward, isn't it? So then I'll talk about why we designed Ballerina as a language and not a sort of a framework on top of other languages, right? So we can talk a little bit about this aspect. And then let's talk about where you can use Ballerina, for which kind of applications. And basically we designed Ballerina as a general purpose language, but as in it supports certain applications better than others. I think usually that's the case for most of the languages, right? And then I'll develop a RESTful service in Ballerina, and my goal is to return the countries with, let's say, hot topic highest COVID case fatality ratio. This service returns you all the countries, or you can query the country by the country code. And in this service, I'm going to talk to two external services over the network. And those services are external services beyond my control. So let's see how it goes. So that's my plan for today. And so, and this talk is not about comparing languages. I'm not going to compare Ballerina versus other languages and conclude which one is better, because languages are designed, even though most of the languages are designed like general purpose, they handle certain use cases better than others, right? There are systems programming languages, there are application level programming languages, there are various class of languages, right? And then we can use the language depending on the task at hand. All right, so just a bit about me. I've been a Java developer since 2007. I work for WSO2. It's a US-based company and I have contributed to the Ballerina compiler runtime, which is written in Java. And then, as Peter said, when you compile a Ballerina program, we generate JVM bytecode. That's the current situation. And then wherever you have a JVM, you can run Ballerina. The compiler produces a self-contained executable jar. So you just need the JVM, nothing else. All right, let's get started. So I've been listening to this talk. I think a tour of modern Java platform happened in November last year in this group. And this slide caught my eye, and it explains what do we mean by modern in this context, right? So it's a way to deal with the increased complexity, how languages and frameworks and software evolve themselves to make it easier for developers to deal with the increased complexity. So what do I mean by increased complexity here? For this context, at least in the context of the Ballerina, we can look at how cloud has changed programming over the years, right? So some rough details here. I'm not going to go through every bit of detail, but in general, we can look at data access and APIs with cloud computing, as in microservices architectures, Kubernetes, Docker, and all these cloud platforms. We tend to decompose application into multiple services, right? Typically called a cloud native application today. And then in these applications, we talk to other systems over the network. And then we use different protocols, like depending on the service and the performance and what kind of information you want to share. Like you use protocols like HTTP, gRPC, GraphQL, WebSocket, WebSub, Kafka. Use different protocols. And then most of the time you communicate over the network, right? Then there are additional complexities in that as well. And then how do you communicate over the network? Basically by by passing network messages, or typically HTTP, JSON or HTTP. And if you look at APIs, now we use network APIs. In the old days, we still use them, but primarily we use off-the-shelf component earlier. We use jars, shared libraries, and we had a big monolithic application. Now we decompose that into multiple systems, so we communicate more and more via network. So, and concurrency is also the same. Like if you remember, I think even in that modern Java talk, they talk about virtual threads, as far as I remember. So Java is introducing virtual threads with Java 19, I guess. So that is a lightweight thread concept on top of the existing Java threads to address some of the concurrency issues or limitations that's in the Java. So what I'm trying to say is languages and frameworks, they are evolving themselves, right, to handle the increased complexity. So you can do that, or else you can take a different approach, as in you can come up with something new with a different set of abstractions, like a new languages, new frameworks to handle this. So Ballerina, we took that approach. We came up with a new language with new abstractions. So if I go to that slide, so languages like assembly and C, when you compare them, C has higher level abstractions than assembly. And then you have C++, Java, Smalltalk, different set of high level abstractions, right? And Ballerina, I think we can say our attempt is to introduce a little bit more higher level abstractions than Java or C++ or Go in that case. I'll talk about them in the next slide. So Ballerina is a modern programming language. I think I can safely say modern now. I defined the term in the previous slide. It is also a pragmatic programming language, in that what I mean by that is it is designed for the industry to write real world applications. It's not a theoretical language. It's a pragmatic language, and it's cloud native, as in it has cloud native abstractions like to communicate over the network and also to run software in the cloud. I'll try to demo all these aspects. The flexibility type means for certain kind of applications, statically typed languages can be a little bit rigid, but dynamically typed languages can be too flexible, as in you lose the type safety to a certain extent. So Ballerina trying to like stay in the middle, like without like delaying certain kind of checks to the runtime, but keeping most of the checks at compile time. You still have type safe type safety, but we have delayed some type checking to runtime so that you have flexible, easy to work with constructs. Data oriented, what I mean by that is, like if you look at all the services and clients, they all communicate data, pure data, not objects. Like objects is data with behavior, right? But in the network, what you see, what you get is data. So Ballerina's primary focus is on plain data, how to represent plain data, how to describe plain data, and how to query plain data. It is not object-oriented language. It has objects and classes, but for the kinds of applications you need to write in Ballerina, you don't have to use objects. You can just use plain data. We can talk about that later. It is not just a language, but a complete platform. Today, you can't just design a language and be done with it. It has to be a complete platform with integrated build system, integrated package management, test framework, API documentation, IDE tooling. You have to have everything to be a complete language these days. Like if you look at Go, Rust, even Kotlin, they're all complete platforms. They have everything in-house and integrated to each other. Our attempt is that then Ballerina maintains familiarity with C-style languages. So the syntax is pretty similar to Java, C# or C++, just to maintain the familiarity. And we think it puts less cognitive load on developers because like if you compare languages like Rust, I think personally, you need a lot to learn before you start writing programs in Rust. I think that is expected from a systems programming language to maintain the safety aspects that it maintains. You need to understand ownership, lifecycle before you write tiny programs. But on the other hand, Java, Kotlin, Go, Ballerina, they don't have that load. Simple languages to learn and use. All right, so I'll talk a bit about relationships to Java. As I said earlier, compiler is written in, and the runtime is written in completely in Java. So if you go to our website, you'll see a lot of Java code, and it generates JVM bytecode, and it provides Java interoperability. It's not fancy as Kotlin, but it gets a job done. If you are writing a Ballerina application and you already have a Java library that you want to talk to, you can use Java interoperability layer in Ballerina to do that. And we have a tool called bindgen that will generate everything that you need to talk to your Java APIs. The other important thing is semantics of the language designed carefully, as in we don't call Ballerina a JVM language, even though it runs on top of the JVM. We don't say it's a JVM language. Our intention is to write a non-Java implementation. So it should generate a native code. And we have a work in progress project on this called Ballerina, native Ballerina, like Kotlin native. So it's also open source. If you go to our organization, you could find all the details. Right, so that's the relationship to Java. Right, I think because I'm the one who is presenting today, I'll take the questions at the end. Hope that's okay. I'll just go through the presentation and we can take questions at the end. So this is just a very simple hello world, Ballerina hello world. Nothing fancy, nothing new. So in the language, we have modules. I'm importing a module and I'm using one of the functions in that module to print hello world. The module has two parts here, actually three parts. We have an organization name, module name, and the version. Version is not in the source code, it's in a different file. So any module that has Ballerina or that starts with Ballerina belongs to the Ballerina standard library. It's managed by the Ballerina platform. Right. So this is okay. The next one is a hello service. So this is an HTTP service written in Ballerina, and as you can see, it has three resource functions. I'll talk about these. So we have get albums by ID, post album. So they have three resources. So idea here, as I explained earlier, Ballerina is trying to introduce network abstractions into the programming language, in the programming language. So as a result, you can see a service construct in the language. This defines a service, and this service is an HTTP service because it is attached to the HTTP listener and port 8080. A service can have a collection of resource functions. These are called resource functions. And there's another construct called remote functions. The idea is, like, if you look at all the protocols today, HTTP, gRPC, GraphQL, you can think of them as, you can see two categories. One is resource-oriented or data-oriented protocols versus the RPC style protocols. Like HTTP and GraphQL, they are resource-oriented, as in you work with resources. That's what REST means, right? So you have actions here. Actions is a get, put, post, delete, patch. then you have the resource, album, orders, customers, anything. So in the resource functions, you can model resources in your REST API like this. And this is a path param, and you can have query params. I'll show you in the demo. Right? If your protocol is something like gRPC, then you would be writing remote functions instead of resource functions. Remote functions, they're just methods. They don't have action. They don't have this verb and noun concept. It's just a method name. Right? I'll show that in the demo as well. So I just want to show you a simple service in Ballerina without implementing, just a high-level structure. And this service returns album. Here, album is a record in Ballerina. This is how you do record, how you define a record type in the language. And what happens here is the get returns an album. And this album is automatically converted to JSON payload by the listener. So as a developer, you can have a nice service interface, and even the incoming payload is album, and outgoing, the return is album. So as a Ballerina developer, you can model your service as a nice service interface, while many of the work is done by the listener on behalf of you, like converting into, serializing into JSON and reading the input and converting it to the payload. Everything happens underneath. This is what I meant by a network abstractions in the language. All right, quick example. I'll briefly talk about the what makes Ballerina unique, and then I'll jump into VS Code. So we can talk about 3 unique aspects of the language, like networking, abstractions, data and types, and concurrency. So in Ballerina, we have services, clients, and network interactions. They are all visible in the syntax. Like I just showed you the service construct, and similarly, we have clients, and network interactions. And these network interactions these abstractions are designed like to be protocol agnostic. They are not attached to any protocol. Like this resource function, even though this is an HTTP resource function, get put post. If you use GraphQL, then the verb could be query. If you're a GraphQL fan, the verb could be query. And likewise, you can change the signature of these resource functions based on the protocol. So they are designed to be protocol agnostic. You can adapt it to your protocol as well. And the language abstractions are there, but the standard library provides support for different protocols like HTTP, gRPC, WebSocket, Kafka. They are all part of the standard library, part of the platform. And another interesting reason is because all these abstractions are available in the source code, syntactically visible, you can visualize any Ballerina program as a sequence diagram. Always. Whenever you write a Ballerina program, if you use these abstractions, or it doesn't matter, you can look at a Ballerina program as a sequence diagram. As in, Ballerina has a text-based syntax, that's a C style, and it has a graphical syntax. The graphical syntax is based on sequence diagrams. I'll show you that aspect in the demo as well. All right, next slide. Data and types. Like when you work, as I said earlier, primary focus is on plain data, how to represent, how to describe, how to work with plain data. And then if I go back to the previous example, you saw that I used the record types to describe the input and output of the service. Right? Same applies to clients. And because of that, you can generate open API descriptions from Ballerina interfaces. You can generate GraphQL schemas, gRPC, protofiles, and all these service ideas can be derived from the service without writing any annotations or anything like that. The next unique aspect is concurrency. So I'm not going to show the concurrency aspects in the demo. It will be a different talk, but I'll briefly mention what are the concurrency primitives that are in the language. We have a concept called workers. So the idea is, I think if you're familiar with Go routines and Go channels, you can you can communicate using Go channels, right? And then you can write pretty powerful programs using Go routines and channels. Workers are not that powerful, not that expressive, I would say, but it's a little bit less expressive, but for some use cases, it's pretty good. So the idea is you write a function and you have a function body. It's when someone calls your function is executed in a thread, right? But in Ballerina, you can break that function into multiple code blocks. We call that they are workers. They are syntactically visible. When you do that, when you call the function, all those workers are executed in parallel, or I should say concurrently. So the idea is, in a function, you can have a worker that logs your response into some logging platform request, and you can have another worker that processes it and send a response back to the client. So there are some use cases, and then you can communicate. There's inherent channels between these workers, so you can pass messages back and forth and all that. And at compile time, because they are all in the same function, we can basically at compile time determine whether you have deadlocks in message passing and receiving combinations. The other aspect is data races. Let's say if I go back to the service, let's say in this service, you are using a module level or a top level variable, and you are mutating a top level variable in all the resource functions. Based on how you mutate, based on whether you are using locks or any other concurrency primitives, the compiler can figure out whether it's safe to call your functions in parallel. Basically, it's safe to call this function while another thread is executing this function. If compiler cannot figure out for some reason, and if it says, look, you're not using any locking, you're just mutating a top level variable, then we don't call resources concurrently or in parallel. That is, Ballerina the compiler can detect that based on, so we can avoid data races. So this will be a separate talk, and there are some concurrency primitives like locks, read-only types, like mutable types, immutable types in the language. You can write a record that is immutable. And then there's another concept called isolated, and you can use all these things to write concurrent code. The other one is strands, which is similar to Go routines and Java virtual threads. They are lightweight threads, and you can write async code with that. So that's it about this. So I'll move on to the next. So I think it's time to write some code. I'm using this Ballerina version, which is the latest version available on our website. So we version Ballerina using famous ballet names: Ballerina Swan Lake, Nutcracker, Giselle, I don't know the next name. So, and then we have a version number so that we can compare and write machine readable code. I'm using VS Code with Ballerina extension. Before I jump into code, I want to basically show you what I'm going to write at a high level. So I think I just came up with this talk like a few days ago. It's interesting. I talk about thinking about the code, and then I followed this talk, and then I wrote a blueprint of what I'm going to build today. So this is what I want to do today. This is what I want to build. It's a sequence diagram. It explains what I want to do. So this is the service that I want to build, lifeline of my service. And I'm going to talk to two separate external services This is COVID data endpoint. This is public. You can try it out. And this is the World Bank API. COVID data endpoint gives you a JSON response. World Bank API gives you an XML response. There's a way to get JSON, but for the demo, I'm using XML, so I can show how you can work with XML. Yeah, I think this idea is you get countries and it gives me JSON response. I loop through the countries in that JSON and calculate the case fatal ratio. If you have the number of deaths, number of cases, then you can easily calculate the ratio. It's just percentage. And then for each country, I want to see whether there's a correlation between the CFR and the income level. So I want to get some World Bank data of a country and then create a combined response and send it. So that's my goal. That's what I want to build. All right, I'll switch to VS Code. Okay. So I'm using VS Code with Ballerina extension installed. And I have already created a Ballerina package called CFR. I'm using the Bal tool. When you install Ballerina, you get this tool automatically installed. Bal is our package manager build system. It has a lot of facets. All right, so I use Bal new CFR to create a new package. And I'm in the package directory now. When you do that, you get two files, main.bal and the toml file. Should I increase the font size or is it better? Okay. I can do it. I think this should be okay. So I'm going to get rid of this side. So Bal is the extension. Source file extension is Bal. Ballerina toml is basically describes the package. We don't need to focus on this today. It's just a meta manifest. And so my intention is to write a service. So I can start with service. So when I do that, I get a list of options. Like I could write file, service, GraphQL, gRPC, all these protocols. They're all part of the standard library, as we said earlier. So I'm going to pick HTTP here. And I'm going to use the base path, void CFR. So it imports HTTP. All right, so now this is a simple service. I can try running it. But it doesn't do anything. It doesn't have any resources. So when I do curl, I think I need to update the port. When I do CFR, let's see what happens. There are no resources, so it should send me, port should be 9090. Okay, all right. Yeah, it's giving me no resource paths. There's nothing there, right? So I can add two resources. One is get. What I want to return is countries. This is the first resource. This will give you a list of countries with the CFR details. The other one is country by ID or code. So this is a path param. That's how we model a path param. So what do we have here? It's just a simple service with two resource functions. Now I can return JSON. That works all right. From both resources. JSON is part of the language, is built-in type in the language. I can do JSON payload equal 1, then return that payload. If you look at the JSON specification, integers, numbers are a valid JSON value. So as string is a valid JSON value. So as Boolean, like value true. Right? They're all allowed in the JSON specification. So, but most common is a JSON object. So let's say your code. I don't know, for some reason GitHub Copilot gives me a nice list of fields. I'm going to use that for now. So this is a nice JSON value. I can return that. That works. If I want to make an array, I can make a GitHub array. I'm pretty sure Copilot is going to give me another value here pretty soon. Okay. So it gave me 2 values. It's pretty useful. So this is sample JSON, right? So I could start writing JSON. So let me delete that first. So what I want to do is first talk to the COVID API. So I'm going to create an HTTP client. COVID data, new. I'm going to get the URL from my note. Give me a second. All right, I got the URL. So this is the service COVID endpoint. And what I'm doing here is I'm creating a client. So this expression is creating client. It can fail because if the URL is wrong or something else. So it gives me an error. So if all works well, I'm getting a HTTP client. If there's an error, then I'm getting an error. So errors are a value in the language. So you can, it gives me a HTTP client error. So this is a union type in the language. So I can model errors as in, and also I can return errors from functions. It's pretty similar to Go. We don't have exceptions in the language, but we have errors as values. You can return errors, you can receive errors from other functions like that. And then you have to, in this case, one option is to check the error before proceeding. So I'm going to do COVID data is error. This is a type test expression. I'm going to check the type of COVID data. If it's an error, I'm going to return that error, or I can do a custom error. Right, I can write a custom error. Let's say just for the demo. Right, and in the next else condition, what I have now is the HTTP client. Now, this is a type test expression in Ballerina, and it narrows the type here. Now, in this statement, the type of the COVID data is a union of client and error, but here it's just COVID data. So I can make a get operation. I can do a get. Yeah, you can just call country code and do a get here. And then it gives me, I think it should give me a JSON payload. And then this is a network interaction, so it can also fail. And I'm getting an error there as well. Right, so all good. But I think you can see the problem. Like if I'm to work with the JSON, I have to filter out the error now. I have another if-else condition. So some cases I don't want to handle errors. Like I don't want to handle every error. I can just return the error from the function. And in this case, if I return an error, the HTTP listener will convert that into HTTP 500 by default, right, based on depending on the protocol. So what I'm going to do is I don't want to go through this if-else nesting. So I'm going to use our check expression in Ballerina, which will basically, if an error occurs, it will return the function from this location. So what I'm getting in the left-hand side is just the client. So I don't need this. I can do the same thing here. So it's a check and payload. Now I'll just return this payload for now. Just the initial. I just want to show the the structure of the payload. I'm going to run it and invoke this method. This is, I think it should be countries / code, let's say US. And I got a JSON, but I can't see the structure properly. So I'm going to pretty print that using this JQ command. So this is the response I'm getting from COVID data endpoint. Right? It has the country name, it has the country code, it has total number of cases, total number of deaths, and population, etc. So a lot of details. Right? I don't want all these details, but anyway, I'll keep it here so that I'm going to use that a little later. Now the next point is these two resources they return JSON, but the problem with returning JSON is the structure of the return, structure of the payload is missing now. If I am to generate an open API description out of this service, in that open API description, I don't see the structure, right? What are the fields? What are their types? Everything is missing. So instead of returning JSON, I could return a type here called country. Right? So this should be an array of countries. This could be just a country. Right? I can define type country as a record in the language. This is, and then I think my notes, I have the complete definition. I'm going to copy it in the interest of time. Right. So this is what I want to send from this service. This country has code, name, population, region, income level, and case fatality. So this is the country that I'm going to send as a response. Right. That's good. So my interface looks clean, and I can generate a nice open API description from this. The next one is, should I work with JSON, or should I work with another record type here? Working with JSON is fine because let's say in the cases, you can, in Ballerina, in the case, you can do payload.cases. It works. There is this cases field here. So you can pretty conveniently navigate JSON in Ballerina like this. But the problem is you don't know until runtime whether there will be a field called JSON or not. So if I write something like this, it will not type safe. In Ballerina, these types like int, they don't, like country, they are not nullable. We don't allow null values by default. If you want to allow null values, you have to explicitly mark as nullable or optional, like in Kotlin. Right? So in this case, this expression returns an error if there's no field. So I have to check to return the error. So the problem with working with JSON is you'll have to always deal with errors. Like next one is I want to get deaths. That's again a GitHub Copilot completing my code. So wherever I work with JSON, I'll have to use errors. So it's not, sometimes it can be cumbersome. So our recommendation is to always convert your JSON payload into a record type, another record type somewhere, intermediate record type. So from the previous experiment, we know the structure of the JSON. So what I can do is I'm going to copy this JSON payload here. This copied, and then in Ballerina VS Code function, we have this little utility called like when I click on this, it will get the JSON payload from the clipboard and generate me a record. Right. So this is what it generated for me. This is a record type. I'm going to name this as let's say with country. as you can see, there are a lot of fields here. And but what I'm interested in this service is cases, country, population, and deaths. I don't want any other fields. They're just garbage for me. So I'm going to delete them from here. I need population. It's going to keep population. And then cases. I need cases. I think I missed one here. So I'll start from here. I don't need continent. I'm going to delete. I'll keep country info and date. So I'm going to preserve these fields, but delete everything else. So now you might be thinking, well, okay, I can use from the country info is another record here, because if you look at this payload, it has a nested object called country info here. So it generates me a nested record as well, but I don't need most of the other fields here, just need the country code, right? So now I'm going to use this country code directly in this statement. Delete all these. So what just happened here, this is a network interaction. It basically do a get on this resource, and then I get a JSON. But because I specify the type on the left-hand side, the HTTP listener basically converts the JSON into the COVID country record. That happened automatically. I don't need to do anything. It's the data binding part. Now I can easily work with this payload. I can do get, and then I can, it's all type safe, because I know there'll be field called death, and that has to be there because I have defined it here. Now, if you look at why I deleted all these fields, the reason is in Ballerina, we have these two kinds of records. We call them closed records and open records. This is a closed record. If you notice the difference in the syntax versus this syntax, you have a curly brace and a pipe. Here, just the curly brace. So we call, this is a closed record in Ballerina, and this is an open record. What do I mean by close and open? Like we use country to send a response from my service. And we used COVID country to accept a response from COVID endpoint. The idea is I am like basically I send exactly what I promised from I'm sending exactly what I promised, right? But when I accept responses from others, I can be, as I say, a liberal. Basically, I know exactly what I want, but I can ignore the others. I don't want them. I'm just defining what I want to do. So the idea here is when you are creating a COVID, the closed record value, when you create a value of this record, you have to specify all these fields, no less, no more. But when you are creating a COVID, the open record, you can create a record literal with these fields plus more. It's okay to add more fields to these open records. We don't care at runtime. Right, so that's the difference between open and closed. Now I can calculate the CFR using payload cases into 100. It has to be here cases. This is deaths, right? So deaths over cases into 100, you get the ratio. Now, this is decimal, and these deaths are integers. So in Ballerina, we don't do automatic numeric type conversion. So we expect explicit conversions in the language. So I'm casting integer to decimal here, same here. So now I get the CFR. So first part of my demo is, I think, okay if I go back to my sequence diagram. I talked to the COVID data, got the response, and calculated the CFR. That part is done. Now, my second part, I'm going to quickly talk to the World Bank API. I'm going to create a client, say World Bank, new. Let me copy endpoint. And also I'll copy the next one as well. So this World Bank gives me an XML payload here. So XML is again another type defined in the language. Right, this you're getting XML from this payload, and then this is string template versus this is in string concat. You can write the same thing here as a string template. Straightforward. So I get XML payload. Now, I just want to see the structure of the payload. Let's do a quick curl here. Curl, I'll use this endpoint to see the structure of the payload. Country, US. Okay, I got an XML payload. It has namespaces, and it has these two elements, region and income level. Right, so I want to extract those fields. So I from the region, I want to extract the value of North America. From the income level, I need this high income for all the countries. Now, if I write a small function saying extract World Bank data and pass W payload, as a response, what I need is these two values. So I'm going to simply create a string tuple. This is a tuple type, and then I'm going to define region and income level and region. Right. So let me copy the definition, function definition. I don't want to write it now. So what I'm doing here is I get the XML payload and define the namespace because it has a namespace, XML namespace, and I query XML value. I'm looking for this element in this XML. I'm looking for that element as well. So as you can see, you can work with XML like it's built into the language syntax, the XML query. And there are a bunch of other functions that you can search like children, text elements, all that. So, okay, now I extracted the elements. Now I'm getting the text values, the text out of these and returning them from the function. All right, I think now I have everything ready to create the country. For the country, I should have code, name, population, and everything. I have the region, income level. I have the, I think, let me rename this variable as, I think I have everything. Let's create a client. That's the last step. Pretty sure so it's a code. I can use this code here. Okay, I'm getting some suggestions from Autopilot. I'm going to use that and see whether that works. So, all right, looks okay. I have the country code, country name, population, region, income level, and case fail ratio. So it's suggested by Autopilot based on my previous work, I think. I was practicing this. So it learns and suggests it. That's all good. Now I can return this. Or else I don't need to have another line. I can just say return. So first, I completed this resource. I'm not going to implement the other resource completely. I can copy the code. So I can give it a try and see whether that works. Let me prepare the curl. What base path is COVID CFR, and then you have countries, US, some. Okay, it says this function return results. So I'm going to return an empty result here for now. And the first section, I invoked the World Bank API, COVID API, then the World Bank API, then created the final value. All right, the service is running. Let me try it. I got a response. I can format it and see what I've got. Okay, I got the ratio, something like this, and I can try with different countries and see, like Great Britain. Yeah, so I can try. So that's straightforward. Then I can do some code improvements here a little bit, just to, like, as you can see here, payload is used everywhere. Payload dot, that's cases, payload. And then there are some duplicates here, the same value, right? Income level, region, right? So we can do some like destructuring. I can destructure the payload record value into different variables. So that's usually what I do. Let's say in that case, I can create new variables for all the record fields. So in the COVID country, there are fields like country, cases. So what I want to do is I want to rename country to name. The name is the variable here. Country is the field in this record, because here I use a name. So that's, I need to map the country to name. Then there are something like cases, field map to cases variable. I could do the same thing here. It's all good. And the other thing is, if the field name and the variable name is same, I don't have to repeat. I can just do the cases. So let me copy the complete one here. All right, so here I basically destructure the payload record into different variables. And now I can use these variables. I don't need to use the payload dot everywhere. This could be name and all that. So this is good. And then here also I can reduce the number of characters. Code in that situation, you don't need to duplicate. It's all good. So this is how you create a new country, right? So I think this is complete. I can just copy the code here for the next resource. I'm going to just show it, and then we can move on to the remaining two items. I'm going to replace this one with the code from my notes. There are two things I have done in the previous case. I defined a function called CFR, but I don't have to do that. I can just copy that for the demo. And then the other one is, sorry, let me copy that function as well. That will be easier. So we have something called expression bodied functions. Here in this function, you have a body, but here you have a single expression. So I'm going to use that here, CFR, like first element, first parameter, depth and cases. And then while I was doing this demo, I noticed sometimes this field is nil in the response for certain countries. Certain countries looks like they don't have a code. So sometimes I get a value, sometimes I get a nil value. So I just mark nil, nullable, so that to handle that situation. And here in the get all countries, I'm doing exact same thing, invoking the COID API to get the countries, and I do some filtering here just to filter out the countries with no code, filter out countries with minimum population, minimum case in the deaths. I'm using query expressions in Ballerina. This is a declarative way to process data, similar to Java streams and C# link queries, right? Like SQL, you declaratively process data, and at the end you create a record, and then I store all the filtered countries here. So this is an array of countries. I'm not going to cover the query expressions, just want to show that we have a feature called query expressions to process data. And then for each country here, for each country in this filtered list, I'm talking to World Bank API and get their data and create an array of countries. That's what I do. And then I return that here. Right? I think the code is sort of complete, and we can try running it. And then I'm going to run it in locally. And then next, I'm going to show how you can deploy this into Docker or Kubernetes. Right, it's running, so I could basically say countries, and this should send me, because I'm using top 10 countries here, the default value is 10, it should send me the top 10 countries with highest ratio. So the first country is this, this is the ratio. The next one is, and you can compare the income level to the ratio, etc. It's just a fun experiment. The next thing is now, I think as I said earlier, we have at a high level, we have the service, resources, and network interactions. So here, this is a network interaction. So we use a different syntax, this is an arrow, versus an object method call. In an object method call, you use dot. But in Ballerina, this is a client and this is a network call, and we use arrows. And the reason is now when you visualize this program as a sequence diagram, you will see the point. So in VS Code, Ballerina plugin, there's this button, the show diagram. When you look at that, you can see the sequence diagram or the graphical view of your code. I have records here. This is my service with 2 resources. These are my functions. And I can open this function and see the sequence diagram of what I just wrote. Right. So here at the beginning, I'm talking to COID endpoint, get some data, and then do some filtering. And then inside the loop, I'm talking to the World Bank API, and at the end return, right? So if I go back to my previous blueprint, it's pretty similar. This is what I want to do, and this is what I end up with, right? The language, every Ballerina program you write, you can visualize that as a sequence diagram. And also we maintain the duality between sequence diagram and the code. Basically, the VS Code plugin, you can edit the diagram. If you are into low code, if you are a low code developer, or if you like to play with the graphical coding, like I can edit here and add an if condition, right? Let's say if true, and save. It should be visible here in the code as well, right? And then I could do another call to this countries API just for fun, and make it COID countries 2. And now if you go back to when you go back to the code or the diagram, you can see that inside the if, there is a call here to the COID endpoint. So we maintain this duality between code and the diagram. the changes, you can go back and forth. The last part of my demo should be like show how you can deploy Ballerina services into Docker and Kubernetes. Now, here what I have is a dependencies TOML file that captures your dependency information, and in the target we have the build, the jar file, right? Nothing else. What I'm going to do here is I'm going to do a bal build -- cloud equals. I could do Docker, or I could do Kubernetes. What this combination does is it generates a Docker file, it generates Kubernetes descriptors for this service. So you can use that. It's a good start for you to, as a developer. If I want to develop my service into Kubernetes, I don't have to handwrite YAML. I can just get started with what has been generated. So go to the Docker directory and click on the Docker file. It generates all these layers, and it knows the port from the code. So this is generated Docker file. And if we look at the Kubernetes directory, this is generated Kubernetes descriptor. We have a service descriptor, deployment, and other descriptors required. Like if you are putting this to production, you need more, but I think what we generate here is good enough for you to test your code in a Kubernetes cluster. So that's mostly about the demo, and I hope I could show you like basic, basically the abstractions and the uniqueness of the language. Unfortunately, I can't cover concurrency aspects, but I think this is what I can do today. Let's see how it goes. Let me go back to my presentation. Just a quick reality check on new languages. I know there are a lot of languages coming up, and then the language to get traction is pretty hard. It takes time. It's not easy because when we are used to languages, and it's hard to change language. Like there are some, if you're interested, read this paper. Interesting information, and very few languages make it to the top 50 or top 20. It takes time, a certain element of luck there. My goal today is to come here and show what Ballerina is, and show the unique aspects of the language. Let's see how it goes. So any questions? So I'll just look at the, let me stop sharing and go to the questions. If you have any questions, also just speak. There's a question, can Ballerina be compiled to native code? Not at the moment, but we are working on a project. It is called Ballerina. It's in a pretty good state. Maybe another year or two, I don't know, maybe another year. We are planning to release the initial version, 0.9 or 0.8, something like that. It may not be complete, but it's the initial version. So we are on that path. In the future, we are maintaining two implementations. One is the current one, we generate JVM bytecode, and the other one is native code. So we're going to maintain two in parallel. Okay. There's another question. Is that a Ballerina dev container in a GitHub repo for us to use? Yes. So when you create a Ballerina package, we generate the .dev container file as well. So if you want to use that in your VS Code in the container, you can develop in that. I guess that was the question. There are other questions. Can you get the type structure record from the schema registry? what do you mean by that? As in, if you have a open API description, then you can generate Ballerina service from that open API description with all the schema types, or you can generate the client as well. I guess that's the question. The other question, the code is written in a blocking style. Is each function running in its own thread, or its pipeline under the covers? So even though the code is written in sequential style, like if I go back to the code quickly, let me see. So even like here, this is a network call. This is a blocking call. I think as is correctly identified. What we do under the cover is the thread, because as I said earlier, we have strands as lightweight threads. So this function, resource function, is executed in a strand, not a lightweight thread. And then when the strand is blocked because of the strand, we release that thread, it can do other things. So the async nature happens underneath. It's not explicit in the code. We don't have explicit async functions in Ballerina. How performance are measured? Is it easy to integrate with open tracing? So Ballerina is built, so especially if you're talking about observability. So the observability, I didn't talk about observability today. It's built into the runtime. Like you can enable observability, and you can publish events to Prometheus, like in Jaeger, and you can visualize what's happening. Hope I answered the question. And performance-wise, Ballerina has, even though Ballerina directly compiled into JVM to implement some of the runtime capabilities of the language, like Strand, we have a small layer on top of the JVM that we call that a Ballerina runtime that has a Strand scheduler, runtime type checker, stuff like that. So the performance, I can say right now, is a little bit less than Java. We have to do actual measurement, but it can be less than Java. How is a strand more lightweight than a regular JVM thread? So okay, I think I'll give you this link. Maybe you can refer this. We have pretty much same concept in the language. Let me just post the link into the chat. This is the Java virtual thread proposal. Java virtual threads are also lightweight threads. The idea here is in Java, at the current Java thread is directly mapped into an OS thread. So there are limitations there, like depending on your environment, right? So what happens here is, like, if that thread is blocked, then it's blocked. But when you have lightweight threads on top of, then you can handle that differently. I think if you read this, you will you'll get that concept. I have another question. Is there any way to contribute to develop Ballerina? Yeah, Ballerina is fully open source. Like, so this is our GitHub repository. This is our main repo, and you can find other repos in our platform. It's fully open source. How do you test Ballerina code? So yeah, that's a good question. So Ballerina, as I said earlier, is a complete platform. Like if you look at the bal command, we have a test command like go test or rust test, and there's and there are ways how you can write test cases. Unit test in the language. You can learn more from the Ballerina website, and once you run test, once you develop all the test cases, you can test them using bal test command. That's all integrated. Is the Strand implementation is based on Quasar? I'm not familiar with Quasar. Let me, I'll get back to you, Alex. Are declared variables immutable? No. If you declare a variable like this, let me go to the top of the page. Let's say int, sorry, not int. I'm going to create a new country. See, if you create something like this, this is mutable. This is by default, this is mutable. You can, if you say read only, and then now the C is immutable. So if you want to, by default, they are mutable. If you want to make them immutable, you have to explicitly say that they're immutable. Alex, yes. So we have implemented our own green threads. We have a strand scheduler in the runtime. I have a last question: how to make more resource functions under different base URL? All right, so if you have different base URL like this, you could have another service, another HTTP service. Sorry, it has to be HTTP. And that, so here, even though I have an inline listener here, you can define this listener as a top level listener. Let's say HTTP list like this, and then you can use it here. And you can share the same listener here as well with another service. So here the different paths could be foo. And now you have resource functions. Let's say orders. Sorry, it has to be get orders. Now you have two different base paths attached to the same port, right? So I guess that's the question. The next, how to make resources visible based on certain roles like admin. I think there is, I have to get back to you based on the RBAC, role-based access control. Usually you can do this via an API management platform as well, but I'll have to, I'm not sure exact details. I'll get back, Suresh, on your second question. So interrupt, okay. So the way to do interrupt in Ballerina, you can write your interrupt functions. For example, let's say, okay, I'm gonna, I think I can open, hope you can see my screen like a Chrome. So I'm going to visit Ballerina website. So an example, interrupt. Let's see whether we have any interrupt. We have some learn pages. Whole Java from Ballerina. So the idea here is, I'll show you a sample interrupt function. Let's see. So our idea is, okay, so let's say you have, so in this use case, what we're trying to do is call SnakeML Java library in Ballerina, right? So if you know the code you want to write in Java, like this is something you want to do, then you will be using the YAML class, map class, and all that. Then, so here are the list of classes that you want to invoke from Ballerina. So our recommendation is write that code in Java first, figure out what classes that you want to use. Then we have this Ballerina bindgen tool, Bal bindgen. You can give the path of your jar using Maven or a physical jar file, and then you can then specify the list of classes that you want to generate, that you want to invoke. Then for those classes, we generate Ballerina bindings, and they become basically Ballerina classes or Ballerina objects, and you can just invoke them in your Ballerina code, right? So that is the approach. I can talk more about that, like how we do that, but I think that will take a lot of time. So the approach is you have Java classes, use Bal bindgen, then we will generate bindings for all these classes. Bindings, basically, they are Ballerina objects. Then you can invoke those Ballerina objects. So this is, then you can have some Ballerina examples here. Yeah, so this is the final Ballerina code. So as you can see, you have the file input stream, file not found exception, then snake YAML, load, right? So these are all generated classes. These are the generated classes. The tool will handle most of the things. You just need to use those classes. All right. I think that's all. Questions? There are a lot of questions. Thank you. Pretty interesting to see all the questions.